Lately, I've been getting into home automation and have found myself needing a bunch of temperature sensors deployed around the house. So I bought these Tuya Wi-Fi temperature sensors, and they've been okay, but my biggest complaint is that they don't really send temperature updates all that frequently. It's got its own algorithm, so it'll do like once an hour if it's not detecting temperature changes are significant, or a bit more frequently if it is changing a bit more significantly, but it's still not as fast as I'd like it to be. And I'm sure they do that to conserve battery power. And while battery power is convenient, I do prioritize fast updates over battery power. So I prefer to have something that's nice and small and cheap, but can plug in and give updates frequently. Now, there is a community that kind of hacks these things and allows you to flash custom firmware on there. So maybe you could do that. But like I said, it's still battery powered, and it'll won't defy the laws of physics. So I have been building my own, which I've been putting around the house, and I'm really happy with. You can find a lot of tutorials online for these Node MCU microcontrollers attached to these DHT11 sensors. And this comes out to be like $2 or something. So it is very cheap. But it's a little unsightly and has a lot of extra stuff that we actually don't need in our deployed sensor. It does make it very convenient for programming and all that. And you've got all the pins to do even more things. So I just wanted to see if I could make something a little bit more elegant than this. And I started designing these with the ESP01S modules attached to these AHT 20 series temperature sensors in this like really compact package, which actually works fine. But after a lot of testing, I found that with these in such close proximity, the temperature sensor is going to read quite a bit higher than the ambient temperature, even though for some reason this is not consuming all that much power either. So I ultimately ended up with something like this, which I'm sure could be housed nicely, but is still more compact than this, even in its current form. So I've got the ESP module here. This is, like I said, the O1S module, some flavor of the AHT 21B temperature sensor here, just connected to power, ground, and the two GPIOs that are available here for the I2C interface. And then everything is connected to this 5 volt to 3.3 volt step down converter. So you can power everything from 5 volts. Now, for the longest time, I was accidentally powering this directly with 5 volts and nothing broke. So I guess it's tolerant to that, but it's probably not best practice to do that for extended periods of time. Right, so to get started, basically wire everything up like you see on the screen now. And then we can start to wire it up for programming. That'll look something like this. All right, and with everything wired up, we can go look at our code now, which is based off of just public reference code for different projects. So this fuses samples from Home Assistant examples, example code from the ESP8266 library, and example code from the AHT sensor library. We've got the boards wired up in the programming mode, and I've not powered them on yet, but I have plugged in the FTDI cable to the computer, and I've installed those drivers, and you can see I have the serial monitor set to 74880 baud, and that way when we plug in the board, we can see the bootloader output. And it's always also a good idea to just keep your serial port in the program at that same baud rate, so you can see the bootloader data and the application data. So let's just plug in the board now. All right, and we should just see this boot mode 1,5, or it might be 1, something else, but that just means we've properly booted in the programming mode, and then we'll be able to flash this code through that cable. So let's just quickly walk through the code here. Like I said, this was just assembled from a bunch of different example codes. So we just import our different libraries here and set up some of our Wi-Fi credentials as well as our MQTT server and credentials. This points to my Home Assistant instance. And then we just instantiate some of the AHT library stuff as well as some of the ESP Wi-Fi as well. Okay, and then like I said, we start up the serial port in 74880 baud. We add our AP, set up the MQTT server, and then we do a check to see if our AHT sensor is alive. You'll notice here the 0 and 2 sets the GPIOs to how we wired them, and then this is just the clock speed. So some boilerplate stuff from the library here, and if everything's okay, we'll get an output that says okay. And then in the main loop, we can call this reconnect function, which will just connect to the MQTT server and try again if it fails. All right, then we get down to our main loop where we have attempt to connect to the Wi-Fi with a 3-second timeout. And if everything connects, then we do the rest of the code. So here's the function to read the temperature from the sensor. There is some serial prints and just some more debugging output if anything goes wrong. You'll see this down below. Here's the portion that publishes to the MQTT server, and then this is just our topic name. We'll take a look in Home Assistant to see how this shows up in a second. Finally, at the end, we have something interesting. So we want to control how often the data gets published and how often the device goes to sleep. So what I've done here is introduce a deep sleep, but this will only work if you solder a pin from the ESP8266 to the reset line. So it's not super difficult, but you do need a microscope and a very fine-tipped soldering iron. So, this is only if you want to run the boards off of a battery. And like I said, I'm not really doing that. So we can just replace that with, let's say, a 300-second delay. And that will publish the temperature every 5 minutes without any special wiring. And you can just run this off of a USB supply. Okay, and then here's that debugging print if there is some kind of error. This is, again, just from the AHT library. So let's go ahead and program this. This will compile. If you do find this getting stuck, in some versions of the Arduino IDE, there is some bug where if the serial monitor is open, the IDE can just lock up. So close the serial monitor if you're finding that that is getting stuck. Okay, so this is how it should look when it's flashing. And now that it's flashed, we're going to unplug it from power. We're going to disconnect the jumper from the IO0 to ground, and then we're going to plug it in and we should see a regular boot. There we go. So now this says boot mode 3 and our application boots, and we should be good to go. Since I've improperly put dummy credentials, this may not do much. So let's put in the right credentials and show you the proper output. Okay, we've got our right credentials in and the application loads up and connects. And you can see here, we've got it every 10 seconds outputting the temperature. So if we go to our Home Assistant now, I've got the MQTT Explorer add-on installed, and I'm just looking at the topic which we've set up here. And so you can see every 10 seconds or so, we get the new temperature value. And now we can turn this into a sensor and use it for whatever we need in our automation setup. So the next thing I want to do is show a comparison between this sensor and the Tuya one, so you can see the benefits of having control over your update interval for the measurements. So just real quick before we look at the results, you have to install something like a Mosquito Broker add-on in Home Assistant to set up your MQTT server, and you can configure the credentials within that. And the next step you would do is in your configuration.yaml file, underneath MQTT sensor, create the sensor that matches the topic in the firmware. So that's the highlighted one here. And then finally, we would have a sensor that looks something like this. This has been collecting data for a few days now. And you can see on the bottom, we have the Tuya temperature and humidity sensor. And then at the top is our temperature and humidity sensor. So you can see the benefits of a 10-second resolution versus an hour resolution. For instance, in the middle here, when in this case, someone was taking a hot shower, you could detect that kind of temperature rise. And of course, if we had the humidity channel here for both sensors, you would see something very similar. So you would miss those kind of events with the Tuya sensor. And those are really useful for triggering automations, like maybe turning on an exhaust fan or whatever else you can imagine. So this is the benefit of having control and high or short interval between your measurements, and why battery power may not be the best for your sensors.